Welcome back. This is Mr. Hassan's Maths channel, and I'm answering question number 6 from the October-November 2023 Pure Mathematics P1 Cambridge 9709. This is paper 1-3, paper 1 variant 3. And this question here is about a straight line which has equation y equals 6x minus c, and a curve which has equation y equals cx squared plus 2x minus 3, where c is a constant. And of course, it's the same constant in both the equations. The line is a tangent to the curve at the point P. The line is a tangent to the curve at the point P. All right, so now find the possible values of C and the corresponding coordinates of P. So a tangent to a curve. So let's just say the curve looks like this. We don't know what it looks like, but say it looks like this. It's a quadratic. Ax squared plus bx plus c. It's a quadratic, so it's going to have either a minimum or a maximum, one turning point only. Okay. Just imagine this is the point P. Just imagine that this is the point P over here. So a tangent to a curve at a particular point is a straight line which just touches or brushes past the curve at that point. So for example, if that's P, then the tangent to the curve at P would look something like this. It would just brush past the curve at the point P without cutting through it. So this would be where the curve and the line meet. Okay, and as this is a quadratic, they will only meet in one place. There's only one place in which they will meet, because this will turn and never turn back down again. All right, so as this is a quadratic, we can solve this equation in a particular way, which is particular to the fact that it's a quadratic, which is that we can say that if we solve these two equations simultaneously, there will only be one root. It will be a repeated root. There will be one solution, and that will be the point where they intersect. There won't be more than one root. There won't be less than one root. There will be one root exactly. Okay, so if we take these two equations, which is y equals 6x minus c and y equals cx squared plus 2x minus 3, and we solve them simultaneously, and the way I like to think about solving simultaneously is to use substitution, especially it will work in every case. In this case, we can also think about it as equating the two, but I don't like to think about it in that sense for every question, because sometimes you don't have things which are as convenient as this. So the best way to think about it is by substitution. So I'm going to take the y in this equation and replace it by what y is equal from the other equation. So I'll end up with here cx squared plus 2x minus 3 is equal to 6x minus c. Now, the solution to this equation should only be one solution. There should be one repeated root. It's a quadratic equation. Let's just rearrange it so it says equals 0. So we have cx squared. We have 2x minus 6x, which is minus 4x. And we have minus 3 plus c, which is like plus c minus 3, writing it in a more friendly way. All right, so I brought everything onto one side of the equation, makes it equal 0. Now, what I know is that when you have one solution, okay, when there's only one root, you know that there's one solution. Therefore, we can say that the discriminant b squared minus 4ac has to equal 0. Okay, now what is the discriminant? Well, if you think about it, this is just a side point. You don't have to write this down in your working. But the quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. And we can see here that this part of the equation of the straight line, the quadratic formula, is very important. This is called the discriminant. If this thing here is positive, you'll have two solutions, two separate solutions. You have minus b plus something over 2a and minus b minus something over 2a. If this thing here is 0, you'll only have one solution. You'll have minus b plus nothing over 2a. And minus b minus nothing over 2a will be just minus b over 2a basically. That would be just one solution if b squared minus 4ac equals 0. And if b squared minus 4ac is less than 0, well, there will be no solutions. They will not intersect. That will be the case where it says this line and this curve never meet. Then you would have b squared minus 4ac is negative, because that will give you no solution. It will give you a math error. All right, so now it's undefined. So now what we want to see the case where b squared minus 4ac is equal to 0, because there's one solution. It's called a repeated root. So in this case, our a, in our formula, our a is c, our b is minus 4, and our c in this equation is the constant, which is c minus 3. Okay, so from the discriminant, we have b squared minus 4ac equals 0. So b is negative 4, so you have negative 4 squared minus 4 times a, which is c, times c, which is c minus 3. Okay, equals 0. Don't get confused between this c and that c. This is just from the formula. All right, so if we solve this, you have minus 16, that'll be positive 16 minus 4c squared plus 12 equals 0. Now we have, you see, a quadratic equation, plus 12c, sorry. Plus 12c equals 0, because minus 4c times minus 3 is plus 12c. So we have a quadratic equation in c, and what we can do is we can make it a bit simpler. Let's divide it by 4c. In fact, divide it by negative 4c. That will give us a c squared as a positive term. So if you divide this term by minus 4c, you're going to get, minus 4, not minus 4c. Can't divide by minus 4c. Divide by minus 4, sorry. You're going to end up with c squared. And 12c divided by minus 4 is minus 3c. And 16 divided by minus 4 is minus 4 equals 0. So now we can find the possible values of c by factorizing this. Now this factorizes. Now please remember to use factorizing. Don't just use the calculator function. Don't just write c equals and c equals. Show that you factorize it first. Otherwise you will definitely lose a mark for that. So here, when we factorize this, we can see the two numbers here must have different signs because their product is negative, and they must multiply to give you 4 and add to give you minus 3. So it must be negative 4 and positive 1 inside the bracket, which means that c is equal to negative 1 or c is equal to 4. Those are the two values of c. And now we got to find the corresponding coordinates of p. So the equation that we solved, which shows where p is, okay, is this equation here. So if I take that equation, cx squared minus 4x plus c minus 3, and I take the other equation, which is y equals 6x minus c, which is the equation that we were solving there. Take those two, and let's say when c equals negative 1, we end up with y equals 6x minus 1, and we end up with minus x squared minus 4x minus 4 equals 0. Okay, equals 0. I should say equals 0 there, right? So you just replace the c with minus 1. So you had this. Now, if I rearrange this slightly by multiplying everything by minus 1, x squared plus 4x plus 4 equals 0. This is going to give us, when you factorize it, a repeated root of x plus 2. X plus 2 times x plus 2. So you have x plus 2 squared equals 0. So x equals minus 2. As you can see, it's a repeated root as we would expect. So x equals minus 2. So therefore, we can say y is equal to, we know that it's 6x minus 1. So you're going to have y equals 6 times minus 2 minus 1, which is minus 12. It's minus, you've got to be careful here. C is minus 1. So this is going to be minus, very, very careful here. That's 6x minus 1, which is 6x plus 1. You've got to be very careful here. Okay, that's a place where I think people would make mistakes. There's 6x minus c, and c is minus 1. So it's 6x minus minus 1. So that gives us actually y equals 6x plus 1. Okay, so that's 6 times minus 2 is minus 12 plus 1, which is minus 11. So therefore, okay, we have when c is equal to negative 1, the coordinates of p are x equals minus 2 and y equals minus 11. So that's one set of answers. Then we got another set of answers when c equals 4. So when c equals 4, remember we have y equals 6x minus 4. This time that's okay. 6x minus 4. Okay, because we know that y equals 6x minus c. And then we're going to have, instead of c, we're going to write 4. So we'll have 4 times x squared minus 4x plus 4 minus 1, which is 1, equals 0. So again, we can factorize this and solve it. When we factorize this, again, this is going to be a perfect square. It should give you a perfect square because you need a repeated root. We can see this is going to be 2x, and you're going to have a minus 1. When you square this, you're going to get 2x squared minus 4x plus 1 equals 0. So we can say x equals a half. Okay, and so that's what x equals. So we know that when c equals, we can now find what y is. Okay, y equals 6 times a half minus 4, which is 3 minus 4, which is minus 1. So therefore, when c is equal to 4, then p is equal to a half and minus 1. Okay, so those are the two possible values of c and the two possible coordinates of p corresponding to them. All right, so that's one way of answering this question, which is probably the easiest way. All right, now this works really because this is a quadratic equation. When you have a quadratic equation, or even, for example, a circle, then the tangent will only meet the curve in one place. All right, it won't meet it. If it's going to be a tangent, it's going to meet it at one place, of course. Right, but if it was a cubic curve, so something like this, you might have a tangent to the curve over here that meets the curve in another place as well. So there won't only be one solution to the equation, but if you were to set it up, you would end up with a question which has more than one solution, but one of the solutions it has will be a repeated root. Where you have the repeated root, that's going to be the tangent. Okay, so that's how you can distinguish between a single answer and a double answer. If it's a tangent, the place where it's a tangent, you will get a repeated root like we got here. Okay, so that's what happens if you have a cubic, for example, and you're able to solve it. You'll end up with maybe an answer and then a repeated root answer. And the repeated root answer would be the place where you get, that's where the tangent is, and the other one will be where it's not a tangent. Okay, so that's another way. If it was cubic, that's what we'd have to deal with, maybe, if that potentially happens. All right, now also, alternative way of doing it is to find the gradient. Okay, you know that the gradient of this curve is, of this line is 6. So if the gradient of this tangent is 6, then the gradient of the curve, okay, at the same point where the p is going to also be 6 at that point. So if we find dy dx, just suppose we found dy dx, that will give us 2cx plus 2. Then we can say that 2cx plus 2 is equal to 6. Okay, and which will give us basically cx plus 1 equals 3. So cx equals 2. So we'll end up with this little point. At the point where p is, then c times x equals 2. And then what we can do is, at the point where p is, the curve and the line intersect. So we can do the same thing. We can say 6x minus c equals cx squared plus 2x minus 3. So then we can just say, all right, let's replace the x with 2 over c. So then you have 6 times 2 over c, which is going to be 12 over c, minus c equals, you'll have c times, and you're going to have 2 over c, which is going to be 4 over c squared, plus 2 times c over 2, 2 over c, sorry, 2 times 2 over c minus 3. So you'll end up with an equation with just c's in it. So you'll end up with 12 over c minus c equals, that will give us 4 over c plus another 4 over c minus 3. If we multiply everything by c to get rid of the fractions, this will give us 12 minus c squared equals, the two c's will cancel, left with 8 minus 3c. So you end up with a quadratic equation. If we bring everything to one side, you'll have minus c squared plus 3c plus 4 equals 0. So you end up with c squared, minus 3c minus 4 equals 0. So then we can solve for c. We'll end up with the same equation, I think, that we got here, right? C squared minus 3c minus 4 equals 0. See, then at that point, it will be exactly the same. We end up with c squared minus 3c minus 4 equals 0. That's where we got to here. And the rest will be the same. So that's an alternative way to get to this point here by instead of thinking about it in terms of the discriminant being equal to 0 when you try to solve these two, that we know that at the point where they intersect at p, the gradient has to equal 6. So the gradient function for this must equal 6. Then you can find what c is in terms of x. And then when you put, when you solve these two equations simultaneously, you can replace the x with 2 over c. and you end up with an equation with just c in it, which gives you this. And then once you got to this stage, it's the same exactly as what we did earlier. I personally think the discriminant is the easier way of doing it, but whichever way you find works, that's fine. And in general, this would be a general way of dealing with it when you have an equation which is, not a quadratic. This discriminant will only work for a quadratic equation. If you don't end up with a quadratic, then this would be the way to proceed with the question. To think about in terms of the gradient being equal at the place where the line is a tangent to the curve. So we should understand how to do it this way in case we don't get a quadratic. Okay, when in a quadratic, we can use the discriminant. Non-quadratic, the discriminant won't work. Okay, so there we have the answer to question number 6. Other questions from this particular paper can be found in the playlist that will appear in this region over here. Other questions from the topic of, I guess this is quadratics. This will be under the topic of quadratics, can be found in this playlist over here. I'll also put a playlist for my quadratics from edXL material in this region over here. You can subscribe to my channel by clicking on this link. Thank you for watching. See you soon.